Hello everyone, welcome to our project presentation. In this video, we are presenting a data structure project titled MediFlow, a hospital appointment and patient care system. This system is designed to stimulate how hospital operations such as patient management, appointment scheduling, emergency handling, billing, and tests can be efficiently managed using different data structures. Problem statement. Hospital manage a large number of patients and operations every day. Tasks like maintaining patient records, scheduling appointments, handling emergency cases, and managing reports can become complex if they are handled manually. The purpose of this project is to design a structured system that organizes these operations efficiently using data structures and algorithms. Objective. The main objectives of this project are to develop a structured system to manage hospital operations, to efficiently store and manage patient records, to implement appointment scheduling using suitable data structures, to manage diagnostic tests using queue-based processing, and to demonstrate the real-world application of data structures and algorithms. Concepts used. In this project, several core data structures are used to implement different hospital functionalities. These includes arrays, linked list, tags, queue, priority queue, HashMap, modular programming, menu-driven interface, and etc. Each data structure is used in specific module to perform operations efficiently. Modules. MediFlow system is divided into 7 modules, each responsible for handling a specific hospital operation. The main module includes appointment queue, emergency queue, patient link list, doctor, bill, test manager, MediFlow main. Now let us clearly understand how this works.
This is the patient class where the variables define the main information stored for each patient. The variables ID, name, age, disease, and severity store the basic patient details and the seriousness of their condition. Two data structures are also used. The ArrayList test stores the list of medical tests taken by the patient. Since the number of tests can change, an ArrayList allows the list to grow dynamically. This block here is the constructor of the patient class. The constructor runs whenever a new patient object is created. It assigns values to the patient's ID, name, age, disease, and severity. It also initializes two empty data structures, an array list for storing medical tests and a stack for storing billing records. This ensures that each patient starts with the structures ready to store their medical data. So this block uses the method which calculates the total billing amount for the patient. A variable called total starts at 0. The method then loops through every bill stored in the stack and adds each bill's amount to the total. And the final total billing amount is returned at the end. Up next, we have the patient linked list class. So this block defines the structure of the linked list. The node represents each element in the linked list. Each node contains a patient object and a reference to the next node in the list. The variable head represents the first node of the linked list. If there are no patients stored, the head is set to null. This block represents the method responsible for adding a new patient to the linked list. A new node is created to store the patient object. If the list is empty, this node becomes the head. If the list already contains nodes, the method moves through the list until it reaches the last node and then attaches the new node at the end. So the remove patient method is used to remove a patient from the linked list using the patient's ID. If the list is empty, the method simply returns. If the patient to be removed is the first node, the head pointer is updated. Otherwise, the list is traversed until the patient with the matching ID is found and the links are updated to remove the node. Then we have the display patient method, which displays all the patients that are stored inside the linked list. This class represents a bill for a medical service. The variable description stores the name of the service while amount stores the cost. The constructor initializes these values when a bill object is created. The toString method formats the bill so it can be displayed clearly with the service name and the price. So finally, we have the doctor class. The ID, name, and specialization store the information about the doctor, while the doctor constructor initializes these values when a doctor object is created. The toString method returns a formatted string showing the doctor's name and the specialization. So that's my part for the project.
Everyone. Today I am going to present my project called MediFlow. So basically in this recording I will mainly focus on two components what I have done in this project. Let me start with appointment queue. The appointment queue is responsible for the managing patient who come for the normal doctor appointments. The queue follows the first in first out principle, meaning the patient who arrives first will be fit at first. So let us look at the code. The appointment queue, this is the appointment queue class. It contains the array front, rear and size. So the front rear means the first patient of the queue, rear which means the last patient of the queue. -1 refers the queue is empty initially. The size which defines the maximum capacity of the queue. So the first method which is used inside the class is appointment queue, which is generally a constructor. The method initializes the queue with a given size. It creates an array to store the object and sets the maximum capacity of the queue. So the next method is enqueue. So this is the method enqueue. The method is used to add the patients to the appointment. Before adding a new patient, the system checks whether the queue is full by comparing the rear and front position of the queue. If the queue is full, then the system or the compiler will print appointment queue is full. Otherwise, the rear pointer moves forward and patient inserted into the queue. So let's move on to the next method in this class is that is dequeue method. The dequeue method is used to remove the patient from the queue when the daughter starts treating them. If the queue is empty, then the compiler prints no appointments. Otherwise, the patient at the front position is removed and the front pointer is updated. So the last method of this class is display method. This method allows us to display all the patients currently waiting in the appointment queue. It starts from the front and prints all the patients up to the rear positions. Now let's move to the emergency queue class. Emergency patients must be treated immediately, but not depending on the principle first come first serve. We use priority queue in this emergency queue class. In emergency queue class, priority queue is an object created. This queue automatically arranges patients according to their severity level. Now let us look at the method in this class. So first method is add emergency. This method add a patient to the emergency queue. When the patient is added, the priority queue automatically arranges the patient based on their severity level. The next method is treat patient. This method removes the patient with the highest priority from the queue. If the queue is empty, the method returns null. Otherwise, most critical patients is removed and returned for treatment. So the last method of this class is view emergency. So this method displays all the emergency patients currently waiting in the queue. In conclusion, this project demonstrates how queues and priority queues can be applied in real hospital systems. Thank you guys.
Let us now move to the next module, which is test manager module. Here, first we create a hash map and then we create a method named handle test. In this method, we give two cases, two switch cases. In the first switch case, we add the test. Like first, it asks for the patient ID. If the patient ID is correct, it gives a list of tests. For example, blood test, X-ray, MRI, etc. It adds the test to the patient ID. If the patient ID is wrong, it simply gives a message patient not found. Then in case 2, we use this case to view the tests. For example, this asks for the patient ID first. If any of the tests are registered on this patient ID, it displays the test. Else, it displays no test. And if the patient ID is wrong, it displays patient not found. Now let us move to the next module, which is MediFlow main. In the main method, all the different modules that we created, for example, appointment queue, bill, doctor, emergency queue, and all other are used. Here we create all the objects of different modules and call each and every method created in them. A menu driven interface is implemented during switch cases, which we can see here, where different options are displayed to the user. Based on the user's input, the corresponding methods from each module, which are called to perform operations like adding patients, booking appointments, handling emergencies, managing bills, and apply medical tests, the system runs continuously inside a loop until the user selects the exit option, ensuring smooth interaction with all modules of the MediFlow system. So these are all the modules. I hope you guys understood the working of the modules. Now let us move to the System architecture. The system architecture shows how different modules of the MediFlow system are connected. At the center is the MediFlow main, which manages the flow of the program. The first one is the patient management and the patient records. These use linked list and HashMap to store and manage patient records dynamically. Then the appointment management, which uses circular queue to manage patient appointments in a first come first serve order. Then the emergency management, which uses priority queue, where patients with higher severity are treated first. Then the test management, which uses a hash map to quickly find patient records and manage medical tests. Finally, billing management. Here we use stack to store billing records and calculate the total bill for each patient. Together, these models create an efficient hospital management workflow. Now, let us understand the workflow. The workflow begins with patient registration, where patient details are stored in the system. After registration, the patient can book an appointment, which is added to the appointment queue. If the case is critical, the patient is placed in the emergency queue, where treatment priority depends on severity level. After consultation, the doctor may assign medical tests to the patient. Each service generates a bill, which is stored in the bill system. This workflow shows how system manages hospital operations from patient entry to treatment level and billing level. Now, let us move to the key features. The MediFlow system provides several important features. It enables efficient patient record management using linked list. Appointments are handled using circular queue to maintain proper scheduling. Emergency handling are managed with priority queue, ensuring critical patients receive immediate attention. The system also supports test management billing, making it easier to track patient service and costs. Overall, the project demonstrates the practical use of data structures in a real-world hospital management system. The main purpose of the MediFlow is to show how data structures and algorithms can solve real-world problems. Hospitals deals with a large amount of patient data, appointments and medical services. Managing these manually can be difficult, right? This system provides a structured and organized way to manage hospital operations efficiently while also demonstrating important programming concepts. Now, conclusion. In conclusion, MediFlow provides an organized system for managing patients, appointments, emergencies, tests, and billing. The project successfully demonstrates the use of linked list, queues, priority queues, stacks, array list, hash map in a real world application. In the future, the system can be provided by adding graphical user interface, implementing online notification, and supporting multiple doctors and hospital departments. This would make the system more scalable and practical for real hospital environments. So that brings us to the end of the project. MediFlow, Hospital Appointment and Patient Care System. Through this project, we demonstrated how different data structures such as linked list, queues, priority queues can be applied to solve real-world problems in hospital management. The system helps organize patient records, manage appointments, handle emergency cases, and much more. This project helps us understand how theoretical concepts from data structures and algorithms can be implemented in a practical application. Thank you for watching our project presentation. We hope this system clearly demonstrates the use of DSA concepts in building a structured hospital management solution. Thank you so much.